Okay. Yeah. So one more thing. So is this way fine, or should we go in some different way from the week second? Do you want to discuss all the concepts or what? Uh,
So that would be better, sir, if you go to week second. So actually, it's a long time, like 7-8 months since the math to I have completed, and a little bit of revision from you will be like great.
okay. Yeah. So, so from next week, what one session maybe we'll just discuss the basic concepts of the whole week, and then we'll take the problem. Just a brief idea about the week. Okay. From the next Wednesday, we'll just ask him to continue. Okay. And today's session, if you are having any doubt, you can just start asking. Any, is my voice very low? Like some of you are saying.
No, sir, it's
Or,
clear, sir. It's clear for me.
okay. So, thank you. Yeah. So if you're having doubts, you can just start, or else you want to have the discussion on some problems first. And
Sir, we will cover week 1 only here, right? Not week 2, isn't it?
yeah. Today we'll just discuss week one only. So I was just asking how to proceed for the second week and all. So like,
Yeah, second week and also I agree with you what you suggested, sir. That out of two sessions, one will be dedicated for concept and the other one for problems, right? Like
yeah.
like solve with us, and also that will be a great help, sir. And for today, I think it will be better if we can discuss questions, sir, so that it will help us to solve graded assignments and even practice assignments.
Okay. Okay. So I'll just go with us that are basically very simple. Like most of them are like theoretical problems. So not much problems are there. 7, 8 problems are there, and then we'll start discussing the practice assignment one by one. Is it fine?
Yes, sir.
Or
Yes,
Yes,
thank
sir.
you.
Yeah,
Yes, sir.
makes sense.
Thank you, sir. Fine.
okay.
And sir, I will request to go like a little slow.
Yeah.
Like mean you tell us the way how to approach that problem solution, because it's not easy for me as of now. So I just want to cope up
Yes.
with the speed, yeah, sir.
Oh,
Thank
okay.
you.
I'll go very
Okay.
slow. Okay. I'll just share my screen. Yeah. So Gurjeet, practices. I mean, question 12. I'll take it after. Maybe it will take 30 minutes to go through the problems, and then we'll start discussing the practice assignment. And even the graded assignment, if you're having any doubts, we'll just discuss the brief concept. Okay. We'll just- Yeah. So this is the first problem. So pretty simple one. Like it's very simple. It's just you need to say these are the data set I have. Like the Arun, I'm just reading of the question. The first question is Arun walks for a run on a daily basis and record the number of steps he has covered on each day using pedometer. Some device is there that generally measures the number of steps he is walking. Okay. So the following table shows the recorded data for a week. He wants to know how many steps he can cover on the next day. So he just want to use some ML algorithm. And so which type of algorithm should he use and why? So somebody has answered like this. You can't.
Prediction,
Uh,
like
what?
supervised learning prediction.
Regression.
Okay, supervised is fine.
Regression.
Okay, yeah,
Supervised
regression.
regression, yes, sir.
Yes.
Prediction is
Okay, so yeah, why regression model we should be?
if we are predicting something, so it seems to be a time series data.
Based on input we are predicting, right? So
Yeah, based on the steps. I mean, we have inputs. We are
Yeah, basically we are just giving some exact values, right? In mathematical inputs we are giving, and then mathematical outputs we are having. Why supervised? Because we have the label of the earlier data. Okay, So it's coming under supervised. And in
Yes.
supervised, why regression? Because the label that we are having, the step number of counts that we are having, it's in the form of some numerical value, some regression value, right? That's why we are using the regression technique. So there's generally two types of supervised. Mostly there are supervised like regression and classification. Classification won't work here because classification generally used to categorize the value. Okay, categorize the labels and all. So here we are not categorizing anything. We are just want the number of steps, and then the number of steps would be some regressive value. Okay, that's why we will use some ML model that would be supervised plus regression. So anybody is having any doubt in this, like at least you are able to know which, if I'm having this type of data, which algorithm should I use, go for. At least a broader perspective of supervised and supervised. In supervised also, which one should I go? Is it like anybody is having any doubt, you can just unmute yourself and can ask. So I'll just wait for that 10 seconds, 20 seconds.
Good afternoon.
Yeah,
Could you please share this question bank with us as well?
yeah, I'll just share with you now, or you want me to share it later? You can see this screen, right?
I was looking to find it, but I couldn't locate anywhere.
Yes,
I
I'll
can see
just
on the
share.
screen, but
Yeah, I'll just
it will
share
be
it
better.
after the session, because this PDF has a solution also. So after this session, I'll just share it. Is it fine?
Okay, thank you.
Yeah. Okay. Thank you.
Yes, sir. Thank you.
Any problem here? Anyone is having any problem in supervisor and supervisor regression classification? You can ask me now, or we'll just move it further. Okay, I'll just go for the second one. Yeah, so this is the second one, and this is the data set I'm having. And for this, I'll just read out the problem. A behavior analyst decided to study the emotional state of his spouse at the end of each day. He decided to observe and record various events or features. So these are the some features, four features, like three features she's having. That happens to her on a daily basis. The table below shows the data collected over a week. Which model would you suggest to him?
Classification model.
Supervised classification.
Yes, sir. Classification.
Why classification?
You can categorize this into happy, neutral, anger.
Yes,
So, but
yes,
till
sir.
now you have read about the only the classification, which can be categorized in two, like either
Mul-
it's a zero or it's a one. So how will you categorize this? Because we are having three, what you can say, label: happy, neutral, or anger. How will you do that? Like,
It's
any,
not binary, it's multi-class classification.
yeah, it's a multi-class. And how generally you do
Like
it's
-1, 0, 1, or 0, 1, 2.
I can give anything to any of the state of emotion. I represent any with any number of my choice.
okay. How will you do that? Any idea about that? How will you generally do for the multi-class classification? Can you give me some idea, like how will you convert this multi-class to a single class, like not single class, by binary class or 0, 1? How will you convert that into a multi-class to a zero?
I will encode like for happy, wherever it is happy, I will encode is like, say, suppose +1, neutral, say like 0, anger, say like -1. That will be a
But
code
that is
in.
also three. But that is also multi-class, like 0, -1, and 1. This is also three, like multi-class classification, right? How will you convert that into a 0, 1?
Binary, you're saying.
Yeah, binary. How will you convert that into a binary classification?
Then we can group two emotions into one.
How will you do that? You will, okay, convert this.
Two into one. So I'll keep anything happy as 1 and neutral or anger as a 0.
Happy.
Okay.
Okay.
But how will you, like, wait, so you just converted this into a 1 and this as 0, 0. Okay. But okay.
So
Then
can
how
I,
will you do? Yeah, go.
so we can classify yes and no as one, and then sum them up, and then according to the value we get, we can define whether it is happy, neutral, or anger. So like if we have 3 yes, that will be equal to 3, then it will be happy. happy. If it is 2, it is neutral. If it is
Okay, that
1,
is fine.
there is
I got your point. You are saying that 1, 2, 3, this type of thing.
So yes is 1 and no is 0 type.
yes is 1 and no is 0, and then
Uh-huh.
we add them up, and depending on the value we get, we will have the predefined label whether it is happy, neutral, or anger.
Like if it is one yes, then and rest of the two things are 0, then neutral.
We
Or
could
like
use
that.
2 bits.
Yeah.
Okay.
Also,
And
in,
in
so
but
in case
Sir,
of
okay, so
hello.
okay, yeah.
Can we use 2 bits of binary values like 0001, something like that?
Whatever you want to take, you can take, but 0, 0, okay. Okay,
00 is happy, 01 is neutral, and 10 is anger.
But that is also a multi-class, right? This is a 3. Like generally, you are just putting some values to happy and some values to neutral and some values to anger. This is what you are doing.
Yes.
It's a multi-class
Yes.
only. For example, this
Okay.
only 3 emotions are there. The 4th emotion can also be there. Some. So how will you do that? One thing you can do is like even like you are having a ML model that is a binary classification only. Okay, and then if you are having a state of emotions like 3 or 4 or 5, in those cases how will you do? You have to use only some ML model which can work on binary classification only. So can you do that like this? You can just take happy versus others, happy versus all the other emotions. This is doable. Similarly, you can do for the neutral versus other emotions. And similarly, you can do for the anger versus other emotions, right? Is this doable? Right? And like you're using, for example, logistic regression. Logistic is a simple like ML model that works for like classification problem, logistic regression. In the logistic regression, you can convert that, or in any of the classification model, you can just convert this into a one versus other, right? One versus other. In that way, you can do, right?
Then we'll need 3 different models.
What you will get 3 different.
Can't do it in one. You have to separate them.
Your voice is breaking a lot. Can somebody? Can someone else speak? Okay.
Sir, but one thing, sir, you have mentioned like you can use a happy versus different other emotions, okay? And similarly for other thing like neutral versus other emotions. So you mean to say we can take any of that example? I mean, any of the approach, only one approach, right?
No. If you are using like for example happy versus other, so you'll be able to categorize happy, right?
So it means like one is happy or not. It means simply yes, no, right? We are saying.
Yeah. Yes, no. You are able to convert that. Yes
Yeah.
or
So
no, whether
yeah.
he is happy or not.
Yes, sir.
Similarly, you
So,
can do for the anger also and neutral also.
yes, sir. I understood, sir. So you mean to say that your approach is to keep only two forms, okay? Maybe 1 or 0.
Yeah, 1 or 0. So this
Suppose
is
you
what
want
I
to
was
go with
saying.
happy, 1 or 0, other emotions are 0, happy is 1,
Yeah,
right?
yeah.
So that's the approach we should use every time. Like we can have multiple values, as you have said, like we can have multiple various emotions here. So the main best approach is to keep only 1 0 approach only, right? One thing.
Like
we categorize them. I mean, we can categorize them.
Yeah. So this is there is nothing best in ML, but this is the generally approach we use in if you are having more than 2 categories. In any disease also, like for person, if any disease, this is like there are 4 stages of any disease. So generally we do like 1 versus other, 2nd versus other, 3rd versus other, 4th. So to just determine this is one of the approach generally we use in ML for the multi-class classification.
Okay.
1 versus other. That yeah, it's a good method.
So does that mean that if there are 4 labels, I have to run it 4 times with 4 different things versus the remaining one? Is it like that?
Yeah, you can just, so 4 times means like we have to code only once, right? You don't have to code 4 times. Like in the coding, you just have to write only one line. Yeah, one line of code. You can run
Yeah,
it.
but I have to run it 4 times, right? Because like in this example, happy versus the remaining, then neutral versus the remaining, then anger versus the remaining.
Yeah, you need to run it twice.
Okay.
This is the one approach I'm saying. This is the basic approach that generally uses in the multi-class classification. Okay. Is it fine till now?
So in logistic regression, so I think it will calculate the probability, no?
Yeah, it generally calculates the probability, and the probability value also you can give it. Like one of the hyperparameter tuning is that value. Like if you want to, for example, if you the pre-default value is I guess 0.5. Like if this is greater than 0.5, the probability value that generally comes as more than 0.5, it will categorize into the one, and if it is less than 0.5, it will categorize into the other category. But you can predefine the probability value also. So what should it take? So that depends on, like, if you are able to plot the probability value versus some classified thing also, you can just get the max, like the optimum value of the probability also, and that you can fix it for the hyper parameter tuning. But generally, logistic is generally calculate on the basis of probability only. It's a probabilistic model. Yeah.
Okay, sir. So, sir, suppose here three classes are there. Okay.
Yeah.
So it will do internal calculation for each class, and which probability is more than 0.5, or what we decide 0.6 or whatever it is. It will give that class yes, and other class are no. On that basis, I think.
Yeah. That's why I told generally use as a one versus other as a in multiple classification.
Understood, sir. Thank you, sir.
Okay. So is it fine? Should I repeat or anything? Any confusion in this? Like logistic will read like all the mathematics behind the logistic, then you'll be able to clarify more, because most of you are not knowing about the mathematics behind the logistic. How does that, any of the regression technique or the classification technique, how does that work? If the maths behind those things, if you will be able to understand, then it will be more clear. Okay.
So one more doubt, sir, here little. Sir, you suggested that we will use the logistic, and sir, we can also use the other one, like decision tree or random forest.
Yeah, decision tree also you can use. Yeah, XGBoost, gradient, the decision technique, or there are so many other like random forest. So you can use that. Like classification problem you can use here.
So is it part of week one, sir? Is it part of week one, sir?
It's a base. Logistic and all is not the part of week one. I just taking one example of the classification.
Sir, please, I request you, please stick to the base week one only. Otherwise, everything will be bouncer for me at least. So just keep referring. I mean, if you introduce more topics, right, in that thing, advanced topic, I think so. So it will be very confusing, sir. Just keep it.
Yes, sir. Sometimes for me also.
At least for week one, sir. At least for week one, at least to keep it basic, sir.
Okay. So this one, like, so this is a general classification problem generally you'll use here. So those logistic and all you'll be reading in the ML techniques, like all the stuff. So many of you are going through the MLT also, but it's fine. So we'll go to the third problem. So the third problem is, like, this is the simple value. This is the data set I took, x1, x2, and y. So this has been plotted here. So this is 0, 0, 1, 0, 1, 1, 0, 1. Okay. And this is a brown one, and this is the, like, so how will you the first problem is, if I'm having this data set like 0, 0, 1, 0, 0, 1, and 1, 1. Okay. And this generally are a cluster of two things. Like this is a one cluster, or I need to have, how will you categorize this two types of data sets? Like the color, it has been
blue and brown.
Yeah, brown and blue. How will you categorize it? Which sort of things, which line, or how will you choose the line or the hyperplane? Which sort of things you'll be using to categorize this?
That I will draw a negative, a straight line with negative slope, and I will segregate the 3 blue points on the upper side and 1 brown points on the lower side.
Oh, fine. But how will you do, like, okay, so you're saying, okay, this can be the one line, right?
X plus y.
All of them are going in the same direction, sir. In between blue and brown, I will draw a line.
A line x plus y equal to 1.
Okay,
Yes,
this
like
line.
this. Yes.
Okay, so how will you choose that? Like there should be some basic approach. How will you choose this line as the best one? So there can be other line also, this line also, there can be some other line also, right? How will you choose that? This is the best one or this is the worst one or anything? How will you choose that?
So minimizing the error.
Minimizing the error. Yes.
Yeah, super. Yeah, this is super. So generally it generally works like this only. Like if I'll just ask the algorithm to choose the best hyperplane to categorize this blue and brown. So how does that work? So generally it calculates as like error. There are so many types of error that generally they calculate, but one is a squared error, and squared error it will calculate the squared error, and it generally works in that way only. It has to minimize the so whatever the optimization problem I'll just give the algorithm to work on. So that optimization problem and optimization problem here is to minimize the square error. Okay, so that if so whichever the plane it will get, like for example, this is one of the best plane to just categorize this blue and brown point, right? So somebody can choose this also. But if you choose this and if you calculate the square error, you will get some values that like for example, this is the hyperplane that I chosen. So this will categorize everything into one category, right? But this is also one of the good. So for example, if you just go through the this like squared error or the loss, whatever you're calculating. So this is the line that I chosen. This is the hyperplane or the plane I chosen. For example, for some this is the 2D plot only. This is the one of the plane I chosen. So what should this if somebody just go to the loss only, if he is calculating the loss, so and he's calculating 0 1 loss, okay, 0 1 loss, like so for him, what is the error? So he's doing the mistake for only 1 point, right? He's just this plane that we have chosen, this algorithm has chosen this plane. This is categorizing these 3 points correctly, right? Only 1 point is that algorithm is doing the mistake for 1 point only, right? So the error would be 1/4 only, right? So this error is not that like not bad, right? Or it's
Yes, sir.
bad. So here we are having only 4 points, right? So if we even like the number of data points that we are choosing here is very less. So even this error is very large, right? Because for this point we were having only out of 4 doing the mistake for 1, right? So 25% of the error. If you just choose this hyperplane, it will not do any mistakes. So it will be able to get the error, minimize the error. Because if you'll calculate the 0 1 loss, 0 1 loss, everybody knows, right?
Yes, sir.
Yeah, 0 1 loss is simply like how many, like whatever the algorithm that you have chosen or the model that you have chosen, how that is categorizing the value. So here, if I'm choosing this and then calculating the 0 1 loss, so it will give me a 0 as a error, right? The loss value. So for this, we can have this as a one of the best or the good model because we are able to minimize the error. So generally we are using a classification problem because we have to categorize it, right? And we are choosing the category and we are able to choose it. Like first we have chosen this as a hyperplane or the plane we have chosen, and then we have calculated the error. Like for example, yeah. So this was the plane, and this was categorizing this whole 4 point in one category and the whole this plane as in one category. And then after we have calculated the error, we got something 0.25 as a squared error. But this was not good. So we have chosen some hyperplanes here and then we have calculated the loss. And we are able to minimize the loss as much as possible. So this you can see, these are 4 points. So I'm having this green one as the one line separator or this is the other one. Can you see me which one is the good one? And first of all, this is not the classification that you have to do. These are the 4 points. This is a regression problem. Okay. And this is a simple example of the linear regression. Okay. One of the most basic algorithms that generally you use in the supervised learning, supervised regression. Okay. So for the green line, like I'm having this A, B, C, D as the 4 data points that I'm having. one features is there and one label is there for each point. Okay, because it's a 2D, so there will be one label and one feature is there. And for each of the points, for each like 4 points, I generally chosen two type of linear regression model. One is the green one is the orange one. Can somebody say which one is the good one? Like, how will you do that? What should be the basic approach? And
We should calculate the loss function.
Using the loss function.
yeah, so the one of the basic approach is to calculate the loss function. On the basis of loss function, you will be able to say, right?
So can you please show, sir, this part, the loss using loss function, how can you come on this conclusion?
Okay, yeah. So these are two linear regression, right? This is the one is the green that you are able to see, right? This is the one model and this is the other one.
Yes, sir.
Okay.
Yeah.
So on this basis, so this was the 4 point, but I was having this data set 4 points. I just trained the model. I got one model as a green one and one model as an orange one I got. Okay. Then I'll check which is the good model out of the two models. Out of this two model, which one is good? So what I'll do, I'll just take this line. Okay. I'll just calculate the distance of each point from this line. This is a one way to do that. Okay. So distance I'll calculate for the A point, it's just passing through. So if I'm having, like, for example, I was having this 4 points. Like, for example, I'm just taking this. I was having this 4 points. This is a simple example. And if I'm able to get this model, this is the one of the, like, this is the best model I can see, because every time if for example I'm getting the next point here, this model is able to predict the value, right? So I was having only 4 points. The 5th point I just got, and this model was pretty able to give me the regressive or the final value or the label of the next or the unseen data set, whatever we got. Okay, so this is one of the best models. So similarly here, I'm having the data set here. I'm having one data set here. I'm having one. Okay, and for this, you can see the loss or the error, you can see 0, because if you are able to calculate the distance of the points on the line or the model, you'll see that the loss or the error that you have got is 0. Okay. Similarly, you can do for this line also. So what you'll do, you just calculate the error, or you can calculate the distance C from this line. Similarly, you will do for this B, and similarly you will do for this D also. Okay, for the green line. So this is the one model. You calculate the distance, or you can say that this is the error also. A squared error, if you have to calculate, just do the square of that. Okay. In the second model, I'm having this is the orange one. So what you'll do, you'll just calculate the value A, the distance, B distance, and the D distance. Where is the C? Oh, C is here. Okay, so you calculate the C. You can see which you'll be able to calculate. You'll be able to see which is having the more error.
Yes.
And whichever model is having the more error, that's not the good model, right? Because that is away from our whatever the predictive value or the whatever the data set I was having, right?
Correct.
Yes, sir.
So this is how the model generally, that the algorithm generally works. If I'm giving some command, okay, so the command generally we give in the form of the optimization problem that they have to solve. Okay, optimization problem can be solved in many methods. So this is the optimization problem. What is the optimization problem here? To minimize the error, the square error, whatever the type of error you are taking up. Okay, so there are generally two types. It depends on the data set also. If you are having the classification problem, then there is a different type of error that you need to minimize. If this is a regression, you can minimize the squared error. Okay, so to minimize the squared error, that I need to give it to the algorithm. Like for example, linear regression is there, so I need to just minimize the error or minimize the error. So what it will start taking the hyperplane, or if it's a 2D, it will start taking the different planes, and for the different plane, it will start calculating the distance. It will start whatever I am giving, like I'm giving to calculate the squared error. So it will start calculating the squared error. Okay, and for those cases, it will give me the model which is having the minimum error. Okay. So, like for example, for this was having the one model, the second one. The orange one, whichever generally gives us the minimum, will be one of the good models. Like out of this two, one is a good one because it's giving me the minimum loss.
Sir, so this is the see the models are given here like the line side. This is the lines only, okay? So 0.5 x plus 0.5 y like that is there. So who decide these models? Are like, do we have to provide the input for this thing, or like the
No,
system will automatically
you don't
produce?
have to provide. Like for example, you just have to use. Okay, just you are just sure this is the regression problem that I need to use. I need to use the linear regression for this data set. Okay, so that you don't have to use like for example, somebody whoever has made the linear regression. In that linear regression, the optimization problem is to minimize the error. You just have to use the linear regression. Okay, I have to use linear regression here for this type of problem. I'll just write the code for linear regression. That one line of code is there. That library that you need to put it there, and for that library, you need to just use the linear regression out of that. So generally, in the data science that you have, you should be aware of the data. Like this type of data is there, which algorithm should I use? Go for that. And behind the linear regression, how does that linear regression work? If you want to develop some algorithm, then you have to work on that also. Okay, how does that work? Like how does that, if I'm having linear regression, how does that linear regression? Linear regression is the basic. So that's why it generally works on to minimize the error. Like for example, the 2D, it can be a 5D or 10D also. In those cases, there are some bigger hyperplane and all. And from that hyperplane also, it will just calculate the squared error from each data point. For each data point, generally it starts calculating for most of the cases. Like it will start just taking the hyperplane, it will calculate the squared error, and whichever is having the minimum error will just show you, okay, this is a model that I got. And then if you just put some next value or some like the next data set, like for example, you are just doing your data science, you have been told to calculate the price of some mobile phone, yeah, and you have a lot of data because nowadays we are having a chunk of data. So you just build a model, and for the next cases, the next mobile phone has launched, and you have been given all the features of the phone, and then you need to predict. So what do? You have the model, and you have the features also, like which of the features you were taking from the earlier phones and all. So whatever the new phone is having the features, you just put it, and then you can predict the company this should be the price of the next whatever the phone you are launching. Did you get the point?
Yes, sir. Absolutely, sir. Thank you, sir. So this linear regression, actually, this is a very important approach. This is, I think, this is the only thing being used in the data science when you work in the industry, right? So mostly people use this linear regression a lot.
Yeah. So nowadays also one of the most used.
Yes, sir. That's what I wanted to put a little pressure on this part. So that's why. Thank you, sir.
Sir?
No, sir.
Hello.
Hey, I'm really sorry. I just lost the connection. My laptop got off. I don't know.
No problem, sir. Okay, sir.
Sir?
Yeah.
Sir, I have a question, sir, related to the regression technique.
Yeah.
Actually, sir, when we have a complex data or a complex data in the linear regression problem. So, sir, I am working on a project. So, sir, I use the linear regression, and that's give me the accuracy R2 score is only 2%, 3%, sir, 3 to 4%.
Oh, this is very bad, right?
Yeah, sir, it is extremely bad, sir. But sir, when I tried basic ANN, it is giving me quite high, 50%, 60%. But sir, my question is this: that sir, is there any way, or you can suggest me anything, paper, any book from where I read that how can I hypertune the neural network? That how much neurons I have to use, what are the layers, what are the activation? So only just uh, yeah, only a book or something, because this is not the topic here today. That's why, sir, only a suggestion that how can I increase the neural net accuracy to the 80 or 90% from the 50 or 60% on the testing data. Any suggestions, sir, will help.
Yeah. So repeat that problem. Like I don't know why my laptop is getting switched off again and again. Whenever I'm putting the vacuum, like the wire of the vacuum inside the laptop, shutting off. So I'll just not use the vacuum now. Okay. So
Okay,
can you
sir.
repeat the problem? Yeah.
Yeah, sir, from the traditional linear regression algorithm, now that is in the scikit-learn, I'm using that on a project, and it is giving me only 3 to 4% accuracy, 2, 3, or 4.
Whether this data is proper or not, like
Yes, sir.
like have you
I
cleaned
did.
the data
Yeah, sir.
properly?
I did the all the pre-processing, and sir, when and then I start using the basic ANN, and so from there I am able to get 50 or 60% accuracy. Okay, sir. After the 50 or 60 epochs. So, sir, my basic question: any suggestion if will help me from you, sir? That how will I increase that from 50-60% to 80% in the basic ANN? Sir, any book or any paper or anything, sir? How I could how I will hypertune that ANN. Hello,
Sir has lost the
again.
laptop.
Okay.
Okay, I think you need to consult with data professionals, people who does work on this kind of thing regularly. So
Yes,
that
yes.
I suggest you can ask this on discourse as well.
yeah,
Like you
it will
can
be
put up
better.
a post there, people who may know they can answer.
Yeah, they can help you.
Yeah. You should put it in discourse.
This is more of a practical or practical question instead of theoretical. I think so.
Yeah.
Without seeing your data, they can't tell you actually. They need to see your data, your problem. I don't think so. You can show them. So I think you need to consult some data scientist.
Asking for a reference, asking for a good book or a good paper or some videos.
No. There is nothing like a good book, sir. Your data is different. Everything concept is different actually. Based on data only you can apply the concept. Unless you see the data, you can't say which book is.
As per his question, he asking some good book that he can read and get some more idea about ANN and all. So I think Andrew NG is offering a course, no? His course is available on YouTube also. Andrew NG, he is father of data science.
Okay.
I'm not sure. I'm not subject matter expert. I've just heard from people like you only.
Okay.
Yes.
Okay. So I don't know what is happening in my laptop. So this is the final time I'm just trying it. If it will get switched off in between, I'll just ask them to maybe shift the session. This is the final time I'm trying because it's been switched off 3 or 4 times. I don't
So
know why this
I think so.
happening.
There is processor problem maybe. It is heating too much, or yeah.
Yeah, it's heating too much. My laptop, I don't know, for the last 3-4 days, it's heating too much. Maybe.
Yeah, so maybe processor heating problem is there.
Well, before you logged out, do we have a session on coming Thursday?
What?
Sir.
Do we have a session on coming Thursday?
Thursday is not like Wednesday you are having, but I just kept like I just told the team to reschedule the timing. If I'll get the reply, I'll just share the timing.
Yeah,
But
because
till now I didn't got that.
calendar is not updated yet.
Yeah, it's not updated. You'll be getting the mail if you get updated. Otherwise, it will be on the same time. I just mailed to team like last, I guess Wednesday or Thursday itself regarding the timing of the
Sir, what are the
Wednesday.
days? What are the days we are having this meeting? This on MLF?
Thursday and Saturday.
Thursday, Saturday.
Wednesday and Saturday now till now.
Sorry, Wednesday and Saturday. Sorry.
Okay, Wednesday, Saturday. Okay.
But Wednesday it is on the
Yeah.
noon session. Working
Yeah.
professional, it's quite tough for
Timing
us
is very
to.
odd. Yes.
Yeah, if it is like after 6 o'clock or 7 o'clock, that would be great.
Yes, sir. I lost the first session, so I'm having the hard time, sir.
Even I was not able to attend the first session.
I think sir is again went
Oh my
off.
God.
No, I'm here.
Yeah. Oh, okay.
Okay,
If
sir,
you ask questions, so the sir laptop will go off actually. Don't ask questions.
Don't ask questions now.
Okay, so should we start now?
So start the session.
Yes, sir. Please.
Yes, sir.
Okay, I'll just ask them to make me the co-host again. Till that time, if you're having any doubt, like you can ask me. I'll just ask them to say, like make me the host again so that I can share the.
Ravi was asking some questions.
Sir, is this course going to be rescheduled? I mean, this same class?
This one?
Yeah.
If my laptop will not work, so I'll just reschedule. Otherwise, it's now working, so it's fine, I guess.
Sir, just ask IIT na. Just give a new MacBook.
They have provided me, but
okay.
that is the same laptop. It's not working.
Okay.
So which laptop they provide, sir?
They have gave me some HP one, good one only, like a pretty one, but it's not working. I'm using it for the last like 1.5 years.
Okay. Sir, yeah, sir, it is from my side is a little question, sir. Using sir, related to the hyperparameter, how to auto-tune best hyperparameter, sir. Actually, I received accuracy of 3% in linear regression, and I tried ANN.
How can you get 3%? I don't know. I've worked so many. How can you get 3% only? I don't know. It's
sir, actually,
totally...
sir, data related to the product and sale. The discount something. So sir, in the linear regression, I am getting only 3-4%. And I also tried other linear regression like polynomial and all the thing, but it is 5%
Did you
only.
tried some random forest?
So random forest for regression type problem.
Why can't you apply?
No, sir, I apply.
Okay, yeah. Random forest also works pretty good for regression also. But yeah, you can. Okay, so mostly you are working on linear regression only. You can't do anything else than that.
Yeah.
Because most of the company generally works on linear regression only.
Yeah. And so yeah, so the thing is that when I tried the basic ANN, I'm giving a quite good accuracy. Sir, it is 60%, 50 to 60%.
Okay, that's also like fine only. Like
yes, sir, it's fine. So my question is that, sir, if you suggest any book or anything that I read, and I know that how to hyperparameter the ANN, how many layers I can use, or how many neurons in each layer. So is there any book or anything? If you suggest, it will help me.
There is a one book, I guess, but okay, I'll just mail it to you. I can't remember I have that, but that I'll mail it to you. Just you can just mail me regarding. You can just ping me hi on the mail. Okay, I'll just get the mail ID from there, your mail ID. I'll just share the 2-3 books are there. But the most important thing is if you have to use so regarding the model, I'll just share the blogs, some blogs that you need to read it. Like generally you would be reading some blogs from the science. There are some data science related blogs. Yeah. One is that analytics vidya is very nice, I guess.
Yes, sir. Yes, sir.
Yeah, so I'll just share you the mail ID. Okay, so it's your name, Rohit, right?
Rohit, sir. Yeah, Rohit Verma.
What's data science is also a very good blog.
Sir, can you, I think if it's allowed, sir, can you please explain about that unsupervised learning for that? We have one topic, density estimation, sir.
Okay.
So
yeah, I'll just discuss that also. After this, just we are having only 2 or 3 problems more, and then we'll discuss.
okay, okay, sorry, yeah, sure.
So, okay, so till now, till here we are done. Okay, so this is the second one. Yeah, so here is the problem.
I think we have third problem, sir. I think.
Yeah, so fourth we are done, right? So this we are discussing. Is there any problem here? How we will we decide which model is good one? If you're using some regression problem, like this is a regression problem, how will you decide?
I think we discussed that based on error with minimum
Yeah.
error. We have to go with
Yeah,
that.
to minimize the error. Anybody is
Yes.
having any problem? So this is the basic ML. So if you are basically clear with this, then I don't think there will be much problem. So the problem generally, like you should not be problem in having choosing the a model at least, like algorithm, which algorithm should you use on the basis of data set. So this regression generally here we are using the linear regression. So the linear regression generally works to minimize the error. So this is fine. Anybody is having any doubt in this? No, right? Okay. Just move it for the next problem. I can't share this entire drive. There are so many important things also. I can't share that. I'll just share this slide after this session.
Okay, sir.
So all the problem quizzes and all everything is there. So yeah, the one thing is, so this is the problem, the fifth problem. The table below shows the original label and predicted label classes for some multi-class. So here this is a multi-class classification problem. Compute the squared error, the 0, 1 loss, which loss functions seems. So the one thing is there. Many of you can say, okay, so this is a classification problem. How are you using squared error loss? So that's a good. If you are able to think that's super. Like why generally we are using here, why you are asking to calculate the squared error loss. I'll just tell you why we are doing this. First, you calculate the squared error loss and the 0, 1 loss. So 0, 1 loss is pretty simple. You can directly calculate without using a pen and paper also. For square error, even that also can be doable. So tell me the value of those square error loss and the 0, 1 loss. This is a multi-classification problem.
So sir, I think if it is matching, then it's 0, otherwise 1, right?
For 0, 1 loss. Okay.
Yeah, so if it is matching, then 0, otherwise 1, right?
Yeah, otherwise 1.
Yes, sir. Yes, sir.
Is it 4 by 11 for 0, 1?
4 and 16 are coming.
Okay. So what is that? 1 by 11 for?
4 by 11 for 0, 1.
Okay, fine. And the other one, the squared error?
That I have to calculate.
Okay. Yeah. So is it fine to calculate a squared error loss for the classification problem?
Can you do one problem so that it will get refreshed?
No, yeah. So I'm just asking whether it's fine. Is it fine to calculate a squared error loss for the multi-class classification problem? Do we need to do like whether it will help us in any way?
No, I don't think so.
Because these are categories, no? They are not like actual numerical values. So the difference should not matter. So I think only 0, 1 error should be helpful in this case. 0-1 loss.
Yeah, fine, correct. Yeah. So, but any other approach, any other thought in anybody's having?
Yes, sir, I have. Sir,
Hmm.
squared error loss, sir, means the original class, how much the original class probability we know it is 100. Okay, what is the truth value or the actual class? And predicted in, if we take second example, that is predicted 4 and label truth is 2.
Hmm.
So, sir, we can check that and in the prediction, what is the probability it is given to the label 2. And from there, we can calculate the squared error, maybe.
Yeah. Some part you told is fine,
Yeah.
but why are we calculating a square error? Is it fine to calculate a square error from the classification problem? Because one guy, whatever he told is told absolutely correct. This is a class only. This class we have given to some label like 1, 2, 3, 4. This is a class. So how it is going to help us?
No, actually, if there is 4 and 1, the label is 4 and predicted is 1, it will show more error. But if it's 2 and 3, it will show less error. But that's not right.
No, I am not talking about that. I'm talking about that there is some there is a probability that model predicted for also the 4, that this row will belongs to.
For that, we have to use logistic regression. But now we are using just sign function. Right? In logistic regression, yes, that makes sense. But here, no.
Okay. So one thing. So don't think about the model now. Just think if this is a 4, if the label is 4 and the predicted is 1, right? So the 0-1 loss will what? 0-1 loss will give you 0, right? Because so the first thing is I can't write, because if I'll put the vacuum, it will, so my laptop will get switched off. So I'll just say so the label is 4. So just understand label. If I'm giving label as a 4, I'll just try to do with the mouse itself. So if the label is 4 and the predicted is 1, is there any? Yeah, so this is the one. This is the problem. If the label is 1 and the predicted is 1, in the 0-1 loss, what it will give you? It will give you 0, right? Because it's not giving, like, the label was 4 and that answer that you got is the predicted model predicting is 1. For this case also, for the 2, 3, 1 also, for the 3, I'll just delete the rest. For 3, if this is a label is 3 and this predicted is 1, for this also it's giving 0, right?
Yeah.
Fine. But if you calculate the square error, it will give you 4 here and 9 here. It will give you 4 here and 9 here. So, okay. So if you are able to, like, for example, in the label, if you have given the label in some chronology, like, for example, this is a disease, stage 1, 2, 3, 4. Like stage 2 will come after stage 1 only, right? The 3 will come after the 2, and the 4th stage, the final stage for any disease, will come after the 3rd stage only. Okay. So if I'm just predicting the stage of some disease, so I'm having this model. This person was in stage 3, but it's predicting stage 1, right? And here it was like for some other patients, stage 4 and it's predicting 1. But for both the cases, if I'm using 0-1 loss, it's giving me 0-0 only, right? And for the squared error, at least I can, if the data set or the label is been put in some chronology, okay, like some ascending or descending order. If if the data set, whatever we have given the label of the ground of truth also in some chronology, it can help us, right? If I'm able to minimize this squared error, like if this model is like minimize the 0-1 and also able to minimize the square error, so what help this can give us, we'll be able to know that if this model, whatever we are having, if this model is having the less square error also, so this will start at least with a prediction. Like, for example, if some person is having the second stage and it's predicting 1, it's at least better than some model is there which is predicting 4 as 1. Are you agreeing? Are you with me?
Yes, yes.
Okay, some model, I'll just repeat this statement. If I'm having one model, there is one model for the stage 2 disease, it's predicting stage 1. If I'm having some other model, it's predicting for stage 4, it is predicting as stage 1. So which one is good? At least the first one is better somehow. It's predicting the second one to 1. The second one is totally like it's predicting the person who is having fourth stage to first stage. At least it's a better one, like the first one. Are you agreeing?
Yeah.
So the square error is helping us a bit. Not
Sir,
much, but helping.
Sir,
Yeah.
the argument which you are taking up is only suitable when there is an order present in a class.
Yeah. Correct. It's not going to help us if this is a multi-class with some only four. This four category, whatever we are giving, it's a random category. It's not helping there. So the square error is not going to help you at all in the classification problem. If you are having some sort of chronology in the label, some chronology is there, then for those cases it may help you. So this is the disclaimer I am putting. Most of the person will generally we don't use the square error first of all for the classification. So this was from the starting I was telling you, for the classification problem we generally don't use the square error because the label, if it's a random some 4 label has been given, how it is going to help us? The square error is not going to help us. 0-1 loss will be helping us because 0-1 will directly classify whether it's classified correctly, it's fine, otherwise not fine. Like it will give you the calculate the error. On that basis, we'll be able to get some model. But if the label is in some chronology, it's going to help us, right? Square error also can help us. If this label is in some chronology, some disease, that example what I was saying you, that is stage example. Are you agreeing?
Yes, sir.
Yeah.
Yes, sir. Yes, sir.
So is this fine? Like, is it clear like why we are using square errors? When can we use the square errors and when we are using 0-1 loss? Any doubt here, like for this problem? Anyone is having any doubt?
No, sir.
Okay. Yeah. So this is fine. So loss function you can calculate. This pretty simple. The basic formula is there. Like square error you can calculate. Similarly, you can calculate this as 4/11 was correct answer. Okay. So this is the last problem, I guess. Yeah. This is the last problem. Consider the encoder W and the decoder W transpose function given below. Okay. So compress the data point X. This is 1, 2, 3, 4 transpose to obtain U and reconstruct the X transpose from U. So after doing this decoder encoder, what the value you'll get? Just tell me the value that is what data you'll get in the end. Do you have pen and paper? Can you calculate?
Uh, 1200.
What?
1200.
How did you calculate so fast, man? Yeah, it's correct one. Totally correct. So it's a pretty like this is an encoder that you need to multiply with X to get U, and then whatever the value you'll get, you just multiply with W transpose, you'll get the final X value. And that is, I guess, 1200 is the correct answer. But everyone should try this. You can get this type of problem in the exam. So this basic matrix multiplication, you should be knowing that. So in the paper, you can get the problem on the logistic I'm saying. You can get the problem on the which type of models are you using and to calculate the loss function. Okay, so this type of problem you're getting in the exam. So all the loss function you should be able to calculate. Okay, so you should not say how will I calculate in the exam. So all the problem will not be that difficult to calculate the loss function and all. So if you are having the basic knowledge, you'll be able to calculate the loss function, like the loss values there also. And some question can be there related to the type of problems will be given. You need to like the options will be given which sort of problem, like which type of problem is this. Okay. So
could you explain this one, sir? Like
what?
Yeah, could you Well, this one's like a encoder and decoder, like W and WT is given and
Yeah. So here is the W is the what do you can say, the encoder that you got. Okay, that you need to pass. Like for example, this is a pathway. Okay. This data set you are transferring. This is the X you are transferring, and this is the encoder. This is the encoder that you have, and then you will get some U. Okay. And then you have the decoder also. The decoder is there. And then in the end, you'll get the data. So it will just compress and then it will decompress the data. And in the end, you'll get some 1200. And if you have been asked to calculate the reconstruction, you'll be able to calculate the reconstruction. As the data set was only one, so you can't divide this with anything. Okay. Are you with me with this?
Yes.
Sir, yes, sir. Yes, sir.
Yeah.
X is 1, 2, 3, 4 transpose it is given.
Yeah, 1, 2, 3, 4 transpose is given.
So then how did you find the L? This is a loss, right? The L is nothing but a loss.
Yeah, this is the loss.
Okay, what is the formula for that thing, sir? Here you have used?
Like, digit by digit that do the subtracts. What is this? Okay, I can't write it. Okay, so this is the formula. I'll just show you. It's been discussed in the lectures also. This is the unsupervised. So is this discussed here? Yeah, so this is the formula that you need to use. The final value what you got 1, 2, 3, 4, right? And 1, 2, 0, 0 you got. So 3 ka square plus 4 ka square upon 1 upon n. N is what 1 here. So you got 25.
Okay, sir.
Is this fine?
Yes.
Yes, sir. Yes, sir.
Yeah. So, okay. So now tell me if you are having any problem in the practice assignment or graded. So this was the basic problems that we have discussed. So just to clarify the doubts and all. And now we'll go to yeah. So week 0, if you're having any problem, you can tell anything from first week. So the basic, I think so basic is clear now. If you're having any problem in any of the questions, whatever is been provided to you, practice or graded, you can just ask.
Hello, sir.
Yeah.
I was having doubt in one of the graded questions. Can I ask?
Yeah.
So, just hold on. Let me take the question. So in question number 16.
Okay, question number 16, right?
Yes, sir.
1 second.
Hello, sir.
Yeah. 1 second, because whatever I was having the answers also. So I'm just opening it in my portal.
Um,
Okay. So now it's visible, I guess. So question number 16.
16,
15.
sir. 16, sir. 16. Sir, in one of the point, it was said that we have to classify the data based on +1 and -1. So if we are getting a 0.0, we can take either +1 or -1.
If you are getting
a 0.0. So if I take in g of x, if I take value 4 and 2, I will get 0 as y equals to 0.
Okay. So you are saying if you are able to calculate it as 0, what should you take? +1 or
Yes,
minus?
sir. Yes, sir.
Okay, it's not been given here. But
It should consider +1, I think, sir.
Yeah.
Yes, sir.
In lecture,
+1 in
in
lectures.
lecture series. Yes, it's consider +1. For 0, +1.
Okay, for 0 you have to calculate take +1 only. I guess in lecture sir has told us in some lecture.
Yes, sir. I heard in lecture, but I missed it at what time sir said it. So when I rewind it, I didn't get it exactly. So I was having this confusion whether I should take +1 or -1.
Okay, you have to take +1. I don't know the timing. Exact timing. Somebody is knowing. Can somebody say like what's the exact time when cells? I guess this is in the 5th lecture itself.
No,
No,
sir.
it will be
Lecture
in
number
4th.
3, sir.
Okay,
Third, yeah, fourth.
Fourth, sir,
Like
4th. Supervised learning.
in the 4th, it should be in the 4th. I'm also not sure. I've seen the lecture very long back.
illustration number 1 and 2 both they.
Yeah, this problem.
Yeah.
Yes, and the next slide, I think.
Next slide, yeah. Yeah, 4. 4. They have taken -1. And for 0, 0, they have taken +1.
Okay, we have to take +1, I guess.
Okay, thank you, sir.
Yeah, so this is the first problem you can see, right? For
But
G,
for
0, 0.
But for 4 it is -1, no, sir. He has taken -1.
What?
For 4, just see point number 4. 4.
The 4th row of X.
4. No,
Okay.
4 will not give you 0, right?
Okay.
0,
No.
0 will give you 0.
Yeah, got it. Okay.
Yeah, so 4 will give you negative value.
Yes, got it.
So you have to take +1, right? Whenever you'll get 0, you can take +1.
Okay, sir. Thank you.
Anything else? Any problem? I guess most of them are same as the practice assignment.
We can ask in graded questions also.
I can tell you the basic approach. I won't be solving the problem.
Sir, practice assignment, last question, in that finding the loss.
Here,
Yeah.
So you have been given the encoder and decoder heads, right? To consider the following data set where each data points consist of 3 features, x1, x2, and x3. Okay, this has been given. Consider a 2 encoder f and f dash. So this is the encoder that you got. So for each of the encoder, you can calculate the value, right?
Yes,
You'll get
yes,
some value.
I did that, and finally, we have to find the loss. For the loss, we have to substitute the formula 1 by n into sigma I equal to 1 to n. So in g of f of xi minus xi. So in g of f of xi, and what value should I substitute in that?
Okay, so you'll get some value from here, right?
Yeah.
That value.
Let us solve one problem, sir.
Yes, 999. 14.
Okay, so I'll just show practice assignment. Okay, I can't write it, but I'll just show the solution.
Yeah.
Writing pad is not supporting today.
Yeah, it's not. So, like whenever I'm putting, should I try that? The laptop is getting off. Should I try it once? I'm able to write with the mouse only, like that, not mouse. That what is a touchpad? Practices. Okay.
Yes.
So yeah.
Okay.
This is the problem. Last one. Is this the same one?
Yes. 10, 10, 9, 13, 12, 30. Yes.
So what you have to calculate, if you have calculated like 9 was the value that you got, right?
Yes, 9, 14, 4, 8. Correct.
14, 4. Okay. So for each value, like you got 9, then the decoder will decode it as 999, right?
Okay.
So 999 it will decode. Then you need to do the subtraction. 9 minus 10 is -1, and again 9 minus 10 is -1, and 9 minus 9 is 0. So you'll get this value, right?
Okay.
And you need to square each of the value, like -1 k square is 1, -1 k square is 1, then add up to 2. Okay. Similarly,
Okay.
you'll do for all the other cases. Like here you got 14, 14, 14. So 14 minus 13 is 1. 14 minus 12 is 2. 14 minus 13 is 1. And do the summation, square of the summation. 1 k square plus 2 k square plus 1 k square. So that is 6. Similarly, you do for all the cases. You do the adding part and then divide it with the number of data points that you are having. So divide it 4 and then.
Okay. Okay, sir.
Yeah.
Also, another problem is there is no mention till how much decimal point we have to answer. So we should enter the answer for rounding off.
For which question it's not been given?
I think graded also is not given. In the last questions. Yeah. Yes, sir.
Oh. Okay, just put it for till 2. Okay, it will take it generally takes the answer in some range. Okay, so don't worry about that.
Okay, sir.
Yeah, so 12th problem somebody was asking practice assignment. 12th problem was the last one. Yeah. So this has been discussed, I guess. So Subhajit, is it fine? You are asking the problem 12th one. Nachiket or Subhajit, is it fine? 12th problem has been discussed now. Any other problem from practice or any activity problem also? Okay, so anyone is having any doubt? Anyway.
So I have a doubt in week 2 practice assignment.
Oh, week 2 will start next week.
Sir, if you want to cover the, can you explain me that unsupervised learning for the density estimation, the calculation? Yeah, if it is, you can take some other questions, no problem, sir. You can take my question after the session anytime, sir.
Okay, in the density estimation.
Yes, sir. Actually, how it is used actually. using the log formula, and also I just want to know like how exactly it is consider the log formula and how it is done.
Okay, fine. Anything else? Anything? Like we have 45 minutes more, man.
So actually, it's just a very small doubt, so if you put in practice assignment. I think the question itself is wrong.
Which one?
In practice assignment 2.
Which question?
Seventh one. Practice assignment 2, sir. Week 2.
Which one? Practice assignment?
Practice assignment 2, 7th one.
He said
So
week 2.
Second week.
It's a second week. Okay. Second week. Okay.
So there is no doubt. That's why I was asking. You just tell. The 7th question, sir. Yes, sir. It's just a constant number, right? So there is no to derivative.
It is part of 0. Oh.
There is no variable in that. There is just a constant, right?
Yeah, there's no variable.
The function.
Okay. Okay, I'll just discuss this 7th one, right?
Yes, sir.
Sir, practice assignment 1.6, question number 4.
Practice assignment 1 point.
Sir, activity 1.6. Last question, 4th. Yes, sir. Even I'm not getting what's the question asking about.
No. So during parameter estimation for a density estimation method. So which type of, so it has been discussed, right? Negative that log likelihood generally used.
So what did my Gaussian matrix model?
Okay, Gaussian mixed model we'll be reading, but I'll just give you a brief idea. Gaussian mixed model is simply you know that normal distribution function, right?
Yes, sir. Gaussian model, yes, sir.
So normal, if you are having a mixture of different like normal distribution function, right? Then you will get to know, then you generally get the Gaussian mixed model. Like for example, I'm telling you, so I'm having a class, okay? I'm having a class of like 100 people, 100 students, and out of that 100, like exam is going on in that class. Okay. And in that exam, you can see that 40%, like I just gave the question paper, and that question paper is having multiple choice problem with 3 options. Okay. So, and all the 100 students are just given the answer randomly, like randomly means they are just like 40% of the people have just given the answer as A as the correct answer. Okay. And yeah, A as the correct answer, and they got some the average marks that they have scored, some random A or some values is there. Similarly, some chunk of people, like for example, 40% of the people has given the answer B as the correct answer, and they have got the average. They got the marks as some marks like B. They have got the marks. Okay, the mean value of the marks. And similarly, the 20%, the rest 20% has given C as the correct answer. C as the correct answer. They have got the mark C. So now we are having in this class, we are having generally 3 types of people, and that 3 type of people means like what? So one, if you'll just predict, plot the normal distribution of the 3 type of peoples, what you will get? you'll get three peak you'll get, right? Three peak means what? 40% of the people, 40 and 20, right? So there are three peak, like, so this is the one of the Gaussian mixture model where you are having a mixture of three normal distribution, but the area should be coming to be one. The area under the curve should be one. Okay, so this combination of simply a normal distribution function. That
Okay, so
generally
it's a mixture of the Gaussian distribution. Is it?
yeah, there's a mixture of the normal distribution that we can.
Okay.
And the area should be one. Should not be. It don't like mix. What you can say. The concept should be like the area should not be equals to 3. Like if you're having 3 normal distribution, because the normally in one normal distribution you generally have the area under the curve as 1, but you are mixing the 3. Okay, mixing the 3 means I just told you 3 type of peoples are there. 3 type of peoples mean 40%. So you'll just multiply the 40% with the first normal distribution, the 40% with the second normal distribution, and the 20% with the third normal distribution. So you'll be having the area as 1. Total area should be equals to 1.
Okay, sir. Okay.
Yeah.
Sir, are we going to study Gaussian mixture model in detail in upcoming weeks?
In the final week, in the 12th week, it will be.
Okay. Okay, will be covered in 12th week.
Yeah, that is been covered in 12th week.
Yes, sure.
So any more doubts you are having? Anything from the first week? Any problem? Any from the activity concept or anything you're having? You can ask me now. Otherwise, from the next week, we'll move to the second week. Second week, we'll just discuss the concept on the Wednesday and then the solve with us and the open session on the Saturday.
Hello. Hello, can you hear me, sir?
What? Somebody saying
hello?
Something?
Hello, sir.
I can't hear that voice.
I think someone asked about density estimation.
Okay. So, okay, I'll just give you the brief idea regarding the density estimation.
Sir, hello.
Yeah.
One small doubt. This graded assignment 1 and 2 has the same deadline of 18/9.
Yeah, it has a deadline, I guess, of the 18th of this month.
Even the week second also. We need
Yeah,
to
week and first and second both.
Okay. Okay. Sir.
Okay. So the density estimation is a type of unsupervised learning. So generally what happens, like for example, you have a data set and you have a data set that is not that sufficient. Okay. So data set, so this like whoever has the doubt. So density estimation is generally useful when you don't have much of data. Like for example, you are doing building some model. Okay. And while building the model, you don't have much of the, what you can say, the data set. So if you're not having much of the data set, what you will do? Like for example, you have a data set, only 1,000 data sets you're having. So 1,000 number of data sets is not a good number of data set to build a good model. Okay. So what you will do there? So there are many methods in the algorithm, like many methods in the ML that you can just increase the number of data sets from the whatever the data set you are having. So how will you do that? So like for example, you are having the 1,000 data set and 1,000 data set, and in that 1,000 data set you are having the features. Like for example, you are having 5 features. F1, like for example, you are having only 3 features and the label is there. So F1, F2, it's too difficult to write with the mouse pad. Okay, so you have 3 features and you are having only what? You are having 1,000 of data set. But this 1,000 of data set is not, if you just train the model on this 1,000 of data set or whatever the data set you are taking, 80% or 90% of the data set. So this data, the number of data set is not that sufficient to build a good model. So what you will do it from here, from here, what you can do, like for example, for 3 features, so all the 3 features will be having 1000 of data set, right? So you'll be having 1000 numbers or the data point for the first features. Similarly, for the second one, you'll be having 1000 features, 1000 data points. Similarly, for the third features also. So what you will do here? So for this F1, so you'll be, if you are having some 1000 plots, you can plot the histogram, right? So if you are having the histogram for this F1 features only, similarly, you can do for the F2 also, F3 also. So if you are able to calculate, if you are having the histogram for the F1, so you can plot the histogram. And if you plot the histogram, so most of you, like you already know, if you just plot the histogram for any of the data sets, you'll start getting a normal type of distribution, right? If you'll get the normal type of distribution from that histogram, you'll be able to get the mean and the variance. And you already have studied the stats, so how to do, like if you are having the mean and the variance, you can reach to the parent distribution of that histogram. Okay.
Yes.
If you are able to know regarding the parent distribution or the main distribution of this histogram, so if you are able to plot that, from that distribution, you'll be able to grasp as number of data point as you want, right? So similarly, you can do for the features 2 also, and similarly for the feature 3 also. So for one feature, if you are able to plot the histogram, and from that histogram, if you are able to know regarding the parent distribution, from that parent distribution, you can like take out as number of data set as you want. Okay. So and there should be some primary conditions and all also. You can't like extrapolate much, but like you can't from the 1000 data set you're calculating 1 crore of data sets. That is not going to help you. From the 1000, you can just extrapolate and can make it as a 5000 of data set, and now you're having a 5000 of data set that can help you in building a good model. So this is simply the density estimation, like it's an unsupervised learning because you don't have the labels and all. Did you get the point?
Yes, sir. Yes, sir. Understood, sir. Understood, sir.
Yeah. Yeah. Anything else, buddy?
Thank you, sir.
Any more doubts? Anything you're having? Of course.
Sir, am I audible?
Yeah, you're audible.
Sir, this is related to nomenclature, right? Say, for example, I am predicting the price of a house, right? And there are 3 variables like area, distance from metro, and other three or four parameters. 3 or 4 variables are there, right?
Okay.
So I think it's a 4-dimensional vector, right? Then in that case, if 4 parameters are there, 4 features are there, then it is a 4-dimensional vector, right?
Yeah, it's a 4-dimensional, correct.
So I will denote it by R superscript 4. Can you write it down, sir? R superscript 4, right?
Okay, R superscript 4.
I will write superscript 4 or subscript 4.
That depends on how you are representing. Okay, R4 generally we represent like this.
So it's a 4. It indicates 4-dimensional, right?
Yeah.
So I have to write superscript. Just asking, confirming. So I have to write superscript, right?
Generally, we read like we write like this. If some books generally writes like if writing in under script, that is also fine. It's a way of representation, but normally most of the books generally write like this, like the way I do.
Okay, but you know, I think in a couple of places, sir has said that, say for example, if I am writing R superscript 3 and subscript 2, or take this example itself, R42, then it means that I am talking about the 4th vector second value. So how to differentiate, because my each vector will be, you know, 4-dimensional, right? So
okay. So the way of representation should not like make any problem in this. Like, yeah, this is like the way he has represented. So he just told in the starting itself, I'll represent like this, so that you should not get confusion, I guess.
No, say for example, my doubt is that, say for example, now I am having 100 data points like that, right?
Okay.
100 rows are there. So each row represents a vector, right?
So you are having 100 of features.
Like here,
Okay, then,
like in above example, you are saying 1000 data points are there. I am saying, just to simplify, 100 data points are there. Means 100 rows are there, right?
okay. No, rows is this one now. 1000 data set is not 1000 rows. That is 1000.
Okay, 100 rows are there. Okay.
Yeah. 1000 rows
So
are okay. Fine.
Each row is representing a vector, right?
Yeah, each row represents one vector.
I think a superscript is represent the number of rows, and the subscript is represent the number of values.
Subscript represents the number of number of columns, right?
Vectors, number of vectors.
No, number of columns. The exact, if I have to locate a,
Okay. One second. I'll just open how sir has represented. I'll just open it. One second. In which lecture he has shown? Second V, which one he has shown? First or second?
You can take any example, sir. No need to go to there also.
Okay.
Yes,
so
sir.
Okay. So, like for example, he has represented like x1, x2, xn is the collection of n data, n vectors, right? N vectors. So this is not the feature. This is the number of data set. x1, x2, x3, x4, xn. Okay. And then he has represented.
No, like 1, 2, 3 are there. So 1 is representing a feature, 2 is representing a feature, and 3 is representing a feature, I think.
No. It's represent like the third point where he has wrote like x1, x2, xn. It's a collection of n data. Like the x1 generally represents the first vector, and if this is represented like xij, that generally represents the jth column. Like that means the jth features of the ith column, ith vector.
Yes, sir.
Did you get? Like aij means jth column. Jth column means the jth features of the ith vector.
No, see, he is writing x22 equal to 8, right? So it means second vector, and the second position, the element is 8.
Yeah.
So it means 1, 2, and 3 are representing separate features. Similarly, 7, 8, 9 are representing the same feature.
1, 2, 3 is representing the different features of first vector.
1, 2, 3 are representing 3 different features. I think one is related to number of rooms, and the other one is related to something area, and the third one is distance from metro, something like that.
Yeah, whatever. Yeah, so 3 features are there. 1, 2, 3. The first features is the 1. The second features value is 2, and the third features value is 3.
So then it's a 3-dimensional vector, na?
It's a 3-dimensional, right?
Then why should I write x superscript 1? I should write x superscript 3.
Maybe this is the third one would be the label.
Pardon?
The third one would be the label, I guess.
No, sir, I am asking exact answer, sir. How can we?
Okay, 1 second. X
X superscript is.
See, generally, see, if this is the right one. If you'll see, that belongs to R3. That generally is simply that is how generally we represent the real vector in 3-dimensional is this one, 1.3 minus 7.6 and the 5.8.
Are you writing something, sir? We are not able to see.
No, I'm not writing anything. I'm just telling you this right one where this is written in this belongs to the R3.
Okay. And
the 3-dimensional, this is how generally we represent for the 3-dimensional thing.
Also, sir, I think this is a row vector both, right?
What?
This R3 can be written in column vector as well as row vector, right?
It can be represented. Yeah, it can be represented in anything like, yeah, it can be represented in the vector and column itself.
Sir, are you there? Sir, are you there?
Yeah. Yeah. Can you hear me?
Yes. Now you are audible, sir.
Okay. So yeah, this is what I was saying. This is the R3, right? The three-dimensional figure. So why are you making like so much of jumbling things? Like here, just a way to represent
I'm not making jumbling things, sir. I'm asking simple question whether it is x1 is x3 or x1. That's what I'm asking.
This x1.
Yeah.
This is the first vector. That's it. This is the first vector whose content is 1, 2, 3. And 1, 2, 3 means what? It's a three-dimensional only, right?
Okay, so yeah, so what you are saying that x superscript 1 is representing one vector, means one row, right?
This is how Sir has represented xi. There can be so many different ways to represent, but Sir has represented x1 subscript x1 as the first vector. So he just yeah. So this does that's the way to represent.
First vector,
You
right?
will not get confused with any problem, I guess.
Okay, so
this is just the way to represent.
This 1, 2 need not to be confused with the dimension of the vector, right?
Yeah.
We should not get confused with dimension of the vector, right?
Yeah.
Okay. Okay, and then sir, my next question was that this I have asked last time also, but I'm not very clear. Difference between length of the vector and norm of the vector, sir.
Okay. So how generally you calculate the length?
No, length is basically square root, right? And we subtract x2 minus x1 whole square plus y2 minus y1 whole square. And then we square root that. That is called length of the vector.
Yeah. And norm is simply the squared value of all the stuffs.
So y2, no sir, I don't think that this is the answer, because y2 then name it differently.
Like for example, see, if you have to calculate, like one vector is been given, and if you have to calculate the norm, how will you calculate the length of only one vector?
Length of a vector is simply square root, of distance. If I am calculating the distance from the origin, then x1 minus 0 whole square plus x2 minus 0 whole square, like that. Hello,
yeah.
sir.
Yeah. I can hear you. So simply the length generally you calculate how x1 ka square plus if this is from 0, under root of that x1 ka square plus x2 ka square plus x3, whatever this has been given.
Right.
And see, norm is simply the squared value. That you can Google also. Even I need to Google what's the difference. Why we generally.
No problem, sir. Then I can Google, sir. Then I can Google and I can read many blogs, sir. Okay, sir. No problem.
Yeah.
And I will share those blogs with you also, sir. I think, yes.
Yeah, you can share with me also. Yeah. So anything else? Yeah. So he's asking what probabilistic model generally, like I was saying you that logistic regression is a probabilistic model. That means what? The final value will come to a conclusion on the basis of some probability value. Okay. And the predictive value, it will come to the conclusions with some predictive value. So probability means it will calculate the probability of some stuffs and then it will come to the conclusion. Okay. So this is the basic difference with the predictive and the probabilistic. Yeah. Okay, Subhajit. Anything else? Okay. So the validation, so the train, test, and validation we have explained in the last session also. I'll just give you an idea regarding the train, test, and validation. So what happens generally if you are having, like, for example, thousands of the data set. So it can be divided into train, test also, and it can be divided into train, test, and validation also. So the mostly we use this validation concept in the ML also. We generally use this concept, but the deep learning and all we generally use for all the cases, because in the deep learning, then even for the training process, it takes a lot of time. Okay, so it generally work as a feedback system. That's why you generally do the validation in the deep learning. But here, what's the meaning, basic meaning of that? If you're having 1,000 of data set, so if you're just dividing it into like 60:40, okay, so 60:40, you are dividing the 10 test data set. So training, you are just doing on the 60% of the data set. You are just hiding some of the data set so that the model will work fine. You are able to calculate the test, like some confusion matrix from that test data set. Test data set is what you are just hiding those data set from the model so that you'll get a better idea regarding how better you can get the confusion matrix, and from that confusion matrix you'll be having a basic idea regarding you'll having the basic idea regarding the model, how does this work. Okay, this was the basic simple example difference between the test and train and test. Now, what is that validation? So generally, if you are having the 1,000 of the data set, you just classify this into test and train. So 80% you have just put for the training data set, training the model, and 20% you have just put for the test. And out of that training data set also, you can just put some 20% for the validation purpose also. And the validation there can be so many other methods to do the validation. And validation generally we do for the model selection. Okay, we can do the hyper parameter tuning also on the validation with the help of validation. Like, for example, there is a one basic method, there is a cross validation method. In that cross validation method, like for example, if you are just putting the cross validation as 5, then what it will do, out of that 8,000 that we have kept for the training purposes, it will classify 20% of the data set for the validation purposes. So for out of that 8,000, it will fix 1,600 as the validation that will do for the train. It will do the training for the 6,400 of the data set. For the 1,600 data set, it will not do. It will work as a unhide. It will work as a hide data set. Okay, out of that 8,000, it will work. It will train on the 6,400. That will not work on the 1,600. On the 1,600, it will help and similarly, if you have fixed the cross validation, like for example as 5, so what it will do, it will take the first 1,600 in the first experiment. It will take the second chunk, second 1,600 for the second experiment. Like, because you have put cross validation as 5, so it will just divide the 8,000 into 5 bags. Each bags will be having 1,600. So for the first experiment, the validation, the first chunk of the validation, first chunk of the data set will work as a validation, and all the other 4, the 6,400 data set, it will work as a training set. Similarly, in the second experiment, it will work the second chunk as a validation and all the rest as a normal training data set. Similarly, it can do for the 5, and it can calculate the mean accuracy, whatever you want to do for the validation also. And that validation can help you in the uploading the what generally say, updating the hyper parameter also. And that hyper parameter is different from the parameter. Parameter is simply the whatever the linear regression, whatever the model you got, the generally the coefficient of the value, the variable is generally the parameter. But the hyper parameter training, that generally we give us to the algorithm to work in a better way. So validation generally help us in those cases to update the hyper parameter tuning and all. Okay, so that generally is the very like the basic thing I told you regarding the validation. So this is the basic difference between the train, test, and validation. So validation generally comes under the training itself. Many of the person generally out of like 80%, 20%, out of that 80%, 20% of the data set generally you keep as the validation. Is this clear, Shweta? Or
so one query over here actually.
Yeah.
In case you said out of the 80%, 20% validation you said, right? So that validation comes afterwards. So is it like we are training the entire thing with entire 80%, and then out of that, after training, out of that 80, we are randomly taking 20% and validating it, or we have to keep it totally separate and not used for training it?
It is kept separate while training the dataset. So you are just training the dataset on the 6400, and you are doing like for the first 1600, for the first experiment, you just kept the first 1600, okay, high as a hidden, and in the second experiment, you did the second bag as the hidden, and you trained the dataset on the 6400. Similarly, you did it for the 5 times, okay, and for the first 1600 that you did in the first experiment, it calculated some confusion matrix. Similarly, you did for the 5 thing, and it calculated the average, and it gave you some confusion matrix, some accuracy, some sort of things they have gave you. Okay, on the basis of those things, you can have a better idea. You can just update your hyperparameters values and all. So there generally helps, the validation generally helps to upgrade the model.
I mean again a bit confused. Like in case of whatever, like if my 80% is say 6,000, okay. So out of the 6,000, 20% I'll keep it aside and never use it during the training. You mean to say that, right? Or I can use that.
Cases, for the first cases, it will not use it, and for the remaining, some like whatever the 20%, the 1200 data set you are having, that will, the confusion matrix will get you can like the same thing whatever you are doing for the test and train. So here the 1200 will work as a test data set. It's not seen.
No. I'm not talking about test. See, suppose forget about 6,000. I'm taking simple 100. Okay, I'm having 100 records. I'm keeping 20 aside for my test. I'm keeping 80 for my train. Right now, out of that 80, I'm keeping 20 as a validation thing. Now, my query is whether I will train my model with total 80, and then after training it, I will keep randomly. I will take randomly.
You are not training with the 80. You are not training with the 80.
Only 60.
You are training with the 60.
And those 20 will never be used for training at any cost. It will only be for validation.
It will be used. It will be used to calculate the confusion. There are so many other stuff that you have to use. We have to do the experiment on the 20 dataset what we have, that is been hidden from the model. We have to do
that will be hidden, na? Those 20% will be hidden from that model and will be used only for the validation purpose, right?
That has been used for the validation. Why we are not showing? Because if it will show, it will give me 100% of the like whatever the matrix that will calculate, it will give you 100% every time, because if you have shown these things to the the model.
Okay, fine. Thank you.
Yeah. Yeah, anything else? Any problem? Anything you need to discuss more? Okay, if you don't have any problems, we'll just close this. We'll just meet on the Wednesday.
Who will be coming, sir? You are only coming on Wednesday?
I don't know. That is not fixed.
Okay. No, because we discussed that on Wednesday we will discuss concepts of week 2.
Yeah. Which 2?
Week 2. We discussed
week
that.
2.
Yeah.
We'll discuss week 2. Okay, thank you everyone. We'll just close this.
Okay, thank you.
Thank you, sir.
Okay,
have a good day.
Okay, have a good day. Thank you.
Thank you, sir.